Hello and welcome to Prime Math Tutorials. Today we'll take a look at graphing the rational function x minus 1 over x plus 3, and hopefully you gain something valuable out of it. The parts of this question are relatively standard. However, it is important to know that if you were given a question that was simply graph this function, it would be useful to go through these steps anyway. So perhaps, for future questions, bear this in mind if you're not given these sub-questions. Now in part A, we are required to find the intercepts. This is usually quite simple, even if the function may appear somewhat ugly. To find the x-intercept, we need to set y equals to 0, or equivalently, f of x is equal to 0. Doing this, we get the equation 0 is equal to x minus 1 over x plus 3, and then we can multiply both sides by x plus 3 to get 0 equals x minus 1. From this, we can find the x-intercept to be x equals 1. Now, we need to find the y-intercept, which is found when x equals to 0. Well, all we need to do is substitute x is equal to 0 into the function, and doing this we get the y-intercept as y equals negative 1 on 3. So there we have it for A. We have the x-intercept as x equals 1, and the y-intercept as y equals negative 1 on 3. On to part B. We need to find the horizontal and vertical asymptotes. To find the vertical asymptote, we need to look at what value of x makes our function undefined. To do this, look at restrictions based on the type of function. Here we have a rational function, which tells us that we cannot divide by 0. Thus we know that x plus 3 cannot equal 0, meaning that x cannot equal negative 3. An intermediary step, which I also suggest you look at if there exists a vertical asymptote, is to see where the function goes to as x is close to the vertical asymptote. A simple way to do this is plug in values such as negative 3.001 or negative 2.999 into the function using your calculator and see what results. Doing this, we get that as x approaches negative 3 from the left side, we get our function going towards positive infinity. And as x approaches negative 3 from the right side, the function goes towards negative infinity. Again, this step is very useful to do as it provides a picture of what your graph will look like when sketching it. Onto the horizontal asymptote. This one is a little tougher as there are a couple of approaches we can take, and all of these will be explored in the later videos. In this function, since the denominator has a leading degree equal to the leading degree of the numerator, that is the highest power of x and the numerator and denominator are both 1, we can then use the limit approach. This involves observing where the function goes to as x approaches infinity, which helps us identify a horizontal asymptote. Now, when we take the limit of x going towards infinity of our function, as shown in this first line, we then need to divide the numerator and denominator by x raised to the leading degree, which is 1. This results in 1 minus 1 on x all over 1 plus 3 on x. Hopefully you can see why we do this. As x goes towards infinity, every term divided by x to some positive power, in this case being divided by x to the power of 1, will then go to 0 as x goes to infinity, since any number divided by a very large value will go towards 0. It follows that we have 1 over 1, which is simply 1, and so our horizontal asymptote is f of x equals 1, or equivalently, y equals 1. Finally, we are now on to sketching the curve in part C. Here, I would strongly suggest that you lay out the information you have gathered in some relatively clean table layout, as it will make this last step much easier. Firstly, we will draw up our axes, sketch in our asymptotes, and plot the intercepts we know. From our table of information, we can put in the x-intercept and y-intercept at x equals 1 and y equals negative 1 on 3 respectively, which I've represented as the small blue dots. Additionally, our intermediary step, where we analyze what happens as x is close to our vertical asymptote x equals negative 3, will help us. Using the information that y goes towards positive infinity on the left side of the asymptote, we can jot a point there indicating the function is going towards positive infinity. And similarly, we can jot a point on the right side of the asymptote at the bottom, indicating that the function is going towards negative infinity as x approaches negative 3 from the right side. Now we are essentially done. We can use the asymptotes and the limit information which we jotted points down then, and the intercepts as a guide to construct the graph. So, before the final graph is shown, let's see how a function that we've plotted here can give us an idea of what the final graph will look like. We know that our graph approaches the light blue dots on either side of x equals negative 3. Starting with the right side of the asymptote, the function needs to pass through the intercepts, but it also approaches the horizontal asymptote of y equals 1 as well. So we'll start from the light blue dot here, go through the intercepts, and approach y equals 1 like this. On the left side of the graph, the function starts at a large value close to x equals -3 and needs to approach y equals 1. Although I didn't specifically show that as x goes towards -infinity, y goes to 1, it is easy to do so using the process shown before. However, asymptotes will be very helpful in getting an idea of what shape the graph has as well. Well, that's it for this video. I hope that you gained something useful and enjoyed it. And if you have any feedback, please comment. See you next time.